Okay, in this video, I'm going to talk about the properties of logarithms and how you would use those properties to solve specific problems. Okay, so what I have over here on the left-hand side are the 10 plus 2 properties of logarithms. Right? Log base A, log of any base of 1 is 0. Log base A of A is 1. A raised to the power log base A of x is x. Log base A of A to the power x is also x. Those are the two inverse properties. The log to any base of the product of two things is the sum of the logs of those two things. The log of the quotient is the difference of the logs. Number 7, if I take the log of something to an exponent, I can pull that exponent out front, and I have the exponent times the log of x. All right, if I have two things that are equal, then I can take the log on both sides. If I have two logs that are equal, all right, as long as the bases are the same, then the two arguments are equal. Right, and then I have the general change of base rule, log base A of x. I can change the base from A to any other base that I want, log base B of x over log base B of A. That's not as useful as it sounds until we look at the two forms of the log that we have on our calculators, and that's log base 10 and the natural log. Alright, so the two forms of this rule that we're going to be using pretty much are this one and this one. Okay. Alright, so we can use these rules to expand a logarithm. Again, as I pointed out in class, something you're probably going to need in calculus. Alright, so what I have to do is I have to find where the multiplication is, where the exponents are, things like that. So the first thing that I have is right here, I've got a multiplication. And according to Rule 5, this becomes log of x plus the log of the square root of x squared plus 2, but I'm going to change the form of that from using the square root to using the exponent form. All right, and this is by Rule 5 that I can do that. All right. Now log of x, there's nothing I can do with that, but over here I've got log of something raised to an exponent. So I can, I'm not going to change that one. But this one, all right, if I look right over here at Rule 7, all right, here's Rule 7, all right, I can take the exponent and move it out in front. All right, so that becomes 1/2 log x squared plus 1. All right, and we're doing that by Rule 7. All right, now there's nothing more I can do because I have nothing that talks about the log of the sum of something. That's just the way it is. All right, so this is right here. This is fully expanded from this original problem. All right, let's take a look at another one. All right, I have another natural log this time, and this time I have a quotient. All right, so the quotient rule is right here. All right, so this becomes the natural log of the top, x squared, minus the natural log of the bottom, x minus 1 to the third. All right, and we can do that because of Rule 6. All right, now both of these logarithms, this one and this one, both have exponents. All right, so I'm going to come down here, and again I'm going to look at Rule 7. So Rule 7 says I can take those exponents and move them to the front of the log. All right, so this is going to become 2 ln of x minus 3 ln of x minus 1. And I can do that because of Rule 7. All right, once I have no more multiplication, no more division, no more exponents, I've expanded my logarithm as far as I can. and that would be the expanded version of what I started with. All right, now we can use this to go the other way too. All right, if I need to evaluate something like this, I can put the pieces back together, and I have to remember to work in reverse order. So working in reverse order means I have to move any multiples of the logarithms up to the top first. So this is going to become log of 7 plus log of 3 squared. And my exponent rule again is right here at 7, so I can do this because of rule 7. And then I have an addition sign here, so addition is over here at rule 5. All right, so I can put those together as multiplication. So I'm going to say 7 times 3 squared. Right, and I can do that because of rule 5. All right, now I can work this out, right? 3 squared is 9. So I get that. And then 9 times 7 is 63, so what I'm looking at here is the log of 63. And then if I wanted to, I could put the log of 63 in on my calculator, and I would get a decimal value out. Okay. All right, but this would be the answer of the combined logarithm. All right, now I have an algebraic one here. And expanded algebraic logarithm, I want to put it back together to be a single logarithmic function. All right, so when I have multiple terms like this, I have addition and subtraction, which means I'm going to be working with the addition rule here and the subtraction rule here. I just work from left to right. Okay, so we'll start 2 at a time here. All right, I'm going to have ln. All right, now I've got this one plus this one. All right, so that's x times 9, so that's 9x. We're going to make a big inside here. And then I'm adding this one in, so that's again multiplication. And then I'm subtracting this one, so that is division. All right, so that is a combination of 5 to get me the numerator and 6 to get me the denominator. All right. All right, so how about we take a look at an equation. All right, so I've got an equation here, 2 to the power x equals 7. Now this is not an easy one to solve because there's no way for me to write 7 with a base of 2, so I can equate the exponents. All right, so what I need to do to solve an equation, anytime you have an equation where you have your variables in the exponent, what you're going to do is use right here, Rule 8. All right. Rule 8 says if I have 2 things that are equal, then I can take the log on both sides. All right, so if I have 2 things that are equal, I can impose a log. I'm going to pick the natural log just because I like it. All right, so I'm going to put the natural log on both sides here. And I can do that because of Rule 8. Now that the log is here, and I'm taking the log of 2 to the x, I have the rule that says I can take the exponent and bring it out front. Right? That's this rule right here. All right, so that says x ln of 2 is equal to ln of 7. All right, and I'm doing that because of Rule 7. Now I have x in a place where I can actually solve for it. Right? This is just multiplication now. So that means ln of 2 is just a constant, so I can divide that out from both sides. And x is equal to ln of 7 over ln of 2. And if you wanted to, you could put that into your calculator and actually, well, you're not going to get it exactly, but you can put it into your calculator, and if you do that, you get about 2.807 and change. All right, so 2.807 ... Okay. All right, now the last example here is evaluating a log to a base that we cannot do on the calculator. All right, there is no log base 5 on your calculator. You can only do base 10 or base E, ln. Right? So we're going to need to use one of the 10s. All right, I want to do a change of base. I'm going to use ln again to do this one. All right, so I'm going to use 10b here. All right, so what I do is I pick my log, which is going to be ln. I take ln of the argument, 89, and divide that by ln of the base, which is 5. All right, once I've made that change, I can, again, approximately equal to, we can put that into the calculator, and when you put that into the calculator, you get approximately 2.779. ... It keeps going. Okay. All right, so there's a few things that you can do with the properties of logarithms.